Hi, everyone. Welcome to our November edition of the Activity webinar. My name is Lee Johnson. I'll be sort of hosting and monitoring the talk as things go along. I hope everyone's enjoying their last couple of classes before Thanksgiving break. Just a reminder, Nick will present and we'll leave everybody in listen-only mode for the recording. If you have questions, please feel free to type them into the window, and if I can, I'll try to sneak those in during the talk. If not, we'll make sure that your questions get answered at the end. So today we're going to be talking about data scraping and modeling with Nick Horton from Amherst College. And so, Nick, I'm going to let you take it away.
Great. Well, thank you very much, Lee and Lori, and as well as all the whole cause team for putting together and organizing the webinar. I've made the materials available, including my slides and the R Markdown files and various other accoutrements at the GitHub site that I have listed here. I'll put that up as well at the end of the talk, just so people can have a chance to download or other things. And if you have other questions and feedback after the webinar, please be in touch. I wanted to really begin by acknowledging kind of the person who did, this isn't my idea, this is Danny Kaplan's idea from McAllister College. And Danny is a man of many ideas, and I'm glad to kind of take this forward as part of some of the work that we've been doing with the NSF-funded Project Mosaic and some of my collaborators listed there. So my goal today, and this is what you signed up for, because this was the description taken straight from the cause website, to describe a classroom activity where pairs of students go ahead and hand scrape data. I think this is a useful way to kind of give a more manual process and feel for bringing in data from the web, which could later be done in a more automated fashion, to ingest those data into R and then carry out analyses between the relationships of price, mileage, and model year for a selected type of car. So this is something I do early in this semester. After a couple of weeks, I've been giving them pretty tame data before that, but to kind of really help them to start seeing the statistical problem-solving process from beginning to end. And the whole process is really facilitated using the less volume, more creativity approach. That's really Randy Prime's mantra that's utilized by the Mosaic and GG formula packages to allow students to start doing things, particularly as they involve multivariate thinking, using a minimal syntax and kind of a small number of learning outcomes that are new to the course. And so the goal here is to introduce and reinforce aspects of data ingestation, multivariate thinking through graphical visualizations and regression modeling. And at the end of the webinar, I'll talk about some extensions and additional uses of the data set that might be helpful for instructors. So cars, and more cars is what I might say here. If you've not looked at the cars.com website or seen some of their ads on the TV, it's a website that lets you look at a particular, for a particular model or type of car. So here I searched for used Mini Coopers, and I found that there was this one at least a couple of years ago for 22.5 with about 10,000 miles on it. And there's a 2011 that's coming in, around the same price but with higher mileage. And this immediately raises this question that I think are of interest to students. Just begin with, like, how much do cars cost? I'm sure that there are a lot of car mad students who really know to a detail what cars cost, but I think other students may not be as familiar with that. And also, we know that, not only is the mean important, but also as measures of variability. So how much do these prices vary? We can start asking other questions. How do those car prices, are they associated with mileage? And so start looking at some bivariate relationships. How do car prices change with age? And then this kind of bigger question, and kind of like a take-home message from this activity, is how quickly do new cars depreciate, and how much would it cost to drive a car 1 mile? To get kind of some sense of what it might be, thinking about kind of quantitative numeracy skills for our students. So a lot of this work is really motivated based on the revised Gaze College report, which came out last year. And as part of that, there was really an expansion of that first point of teaching statistical thinking, where we really wanted to talk about ways of teaching statistics as an investigative process and give students multiple experiences with multivariable thinking, where they start to think beyond just two different variables. I think the other aspects of this activity that are attractive are that it integrates real data with a context and purpose very explicitly. It fosters active learning, and it really does use technology to allow exploration and analysis. So what's the motivation for multivariate thinking? And again, I very much am concerned. We live in a multivariate world where it's full of observational data. My biggest concern is if interest stats only addresses bivariate questions, like a two-sample t-test of a randomized trial that's fully adherent and there's no dropout, we risk becoming irrelevant. Students leave the course thinking there could be other factors, and that leaves them paralyzed in some other ways. And I think one of the big advantages we have right now, teaching as we are, is that the technology, the degree of difficulty and the power of it has gotten so much better in recent years. The Project Mosaic is just one approach. We published an R journal paper that describes the less volume, more creativity, but we really now have the mechanism with a very small amount of syntax and straightforward commands to let students really start to explore in these kinds of ways. So the Cars.com activity, the way I've set it up, it's done with groups of size 2. That could be changed. I think that would be a minimum. It can be 1 or 2 50-minute class periods or 1 80-minute period. The requirements ideally are 1 computer per student, and the software, one of those computers would be wanted to run R in our studio, either a cloud-based server, which is what we do, and again, that makes our life dramatically easier. The students just need to bring a browser. They don't need to install anything on their computer. And the other one running something like Excel, OpenOffice, or Google Spreadsheet, just the ability to kind of have a spreadsheet open. And again, we want to start with some motivation for the students. Why might they care about car prices? So then each of the activity, each of the groups is given a major city in the U.S. I want to start to see if there are any kind of regional differences as they collect these data. I'll eventually be collating it all. So Atlanta or LA might be 2 of those. And then they complete this process to try to generate data on about 40 cars. Person 1 will search Cars.com. I picked Toyota Priuses. They want them within 50 miles of that city. The other person downloads a template spreadsheet that has the names in exactly the form that I have, capitalization and naming, so that when we collate these things, or when they go ahead and upload this, the code that I provided for them in the R Markdown document will actually let them do analysis in an automated fashion. So then person 1 will go ahead and read out the car models, year, mileage, and price, 1 by 1. Person 2 will enter those values into the spreadsheet and then kind of repeat that number for person 1 to check. And they'll continue doing that until there's been about 40 of these entered. What's always remarkable to me is differences in efficiency for students. So some students in the same time, maybe only take 5 minutes to get started, only do 15 or 20. At some point, I cut things off and have people move to the next level. To kind of close this section of the data generation, person 2 will then email person 1 that cars.csv spreadsheet, so both of the members can upload this into RStudio. So the next step will be in RStudio, there's also a file, I've made this available on the GitHub repo, called student.rmd. This is an R Markdown file that reads the cars.csv file. It'll go ahead and generate descriptive statistics. It'll show you how things are being coded. So if there's some inconsistency in how things are put together, commas or dollar signs, it'll indicate that with an error message. It'll go ahead and create visual multivariate displays, so some scatter plots, possibly stratified by year, of mileage by price. And then it'll also go ahead and fit a very simple regression model and report the coefficients from that model. And this really provides scaffolding for the additional analyses I want them to do. So first part of the analysis is just make sure they have things coded. The cars.csv got put into the right folder. It has the right titles. It's in the right format. They can go ahead and run this kind of default, like a sanity check. So then the next step for them is to really go ahead that once that's running without error, really start some creative step. Their assignment here is they need to find in 10 or 15 minutes an interesting display and fit a multiple regression model with at least 2 of the variables that are included in the analysis. And the real goal here is to try to make some kind of insight. These get published on the rpubs.com. This is an open access place where people can just use, in this case, a class-wide login to kind of put things up there. I'll delete them after the class. But it's a way for me to kind of have them share with the class, and then I can just, on my display, move from one-to-one to talk through some of their insights. This is early in the semester. I want to make sure that the students know each other to some extent, so they get full credit for an email to the instructor that's CC'd to their partner of their modified student.rmd file and their own version of the cars.csv file that they've created. I can then go ahead now and collate that, and that's what I will be doing later on. But first, let's just see how this looks on the student end. They've run this student.rmd file. I've run the glimpse command on the data frame called DS. It says there are 40 observations there. You can see that these are Priuses from Atlanta. It shows us the first couple of values. I can run the favstats function in the mosaic package that shows me that the prices go from about $14,000 to about $22,000 for their cars, but the mileage goes from about 6,000 to 60,000 miles. So we get some kind of sense of the distribution. There's, by default, a set of parallel side-by-side box plots where we can see that, as you go from right to left, the prices drop. The newer cars tend to be more expensive than the older cars. And then similarly, there's a relationship between the mileage of the car on the x-axis and the price. Here I'm using the GG formula commands to put on that scatter plot and overlay that smoother. And so kind of just starting to get some sense of what these relationships are. We see that this is not a linear relationship. That might be a possible extension for later on, but for right now, kind of really keeping things simple as they proceed. So they've handed this thing in. They're pretty much done with it. They've found some kind of insight. What I will then do with the data sets that they provide are to collate the individual group data into a file that I've made available to you as Cars Collated 2017.csv. And that file, I need to do a little bit additional data cleaning. There might be some inconsistencies in how people are coding things, but I'll end up adding location as a categorical variable with a lot of levels to the multiple regression model, and then help the students to practice interpreting those multiple regression models with a categorical predictor with many indicators, like a fixed effects model. And then also interpreting interactions, which is never easy, but there's clearly a strong relationship between mileage and year. And to kind of talk about and think about an interaction like that with the idea that we're trying to get insights on the depreciation. That's particularly dramatic for new cars. No surprise for instructors, maybe a surprise for students. And again, there's lots of kind of ways of introducing some of that context and background. Tom and Ray Magliazzi, Tom, alas, may he rest in peace, had a blog entry talking about this aspect of when's the right time to buy a car, how long do you keep it, et cetera. And essentially, from the economic thing, you want to buy an older car and then drive it into the ground. There may be different things people are valuing, but that part is what this is really focusing on. When I start looking at the data that's been collated, I have 831 observations, and you can see there's a little bit of weirdness there. There's two 2017s, which were new cars, so contrary to my instructions to only pick on used cars, and 2007. I went ahead and dropped those just because there wasn't really much data on those times. And you can see kind of just a set of some of the locations where the students were looking for these. I spend a lot of time in my Intro Stats course talking about and interpreting multiple regression, and a lot of it really purely descriptively. This is probably the third week in the class. We've seen simple linear regression. We've seen multiple regression, much simpler, maybe two predictors, maybe a parallel slopes model with one categorical predictor and one continuous one, and even the kind of dreaded, two slopes, that the men and the women maybe have different slopes. This is a more complicated example. We have mileage as a quantitative variable, but we have year as a categorical variable, the way it's being set up here as a factor in R, with 6 different levels. So we end up having a 5 degree of freedom interaction that you can see by these terms. So I don't start there. I start with these location effects, and we kind of talk about that, the idea that this is saying that the prices all things being equal, tend to be a little bit lower in Tampa and higher in Seattle. We're not kind of looking at inferential statements at this point, so it's kind of leaving that for right now, but just describing those trends, kind of talking about what the reference group is, the alphabetically, first in the alphabet is what that will be. And then going ahead and thinking about what's going on in terms of these interpretations. Mileage here, and again, students are always warned to be careful about interpreting main effects in the presence of interactions. Again, you have to be very careful as you start thinking about this. But that mileage slope is really thinking about what the term would look like in 2011 as the reference. And what it's saying is that in 2011, it costs about 6 cents in terms of decreased car value for every mile that's driven. So for every additional mile, I think the price goes down by about 0.06, sorry, about 6 cents. But if we contrast that with the interaction term for 2016, we see there's an additional 18-cent hit that for every additional mile in 2016, we would expect a car holding location fixed to cost about 24 cents less. And that's kind of a very useful insight to try to make sense of these data, that depreciation effect I talked about. There's still a lot of error in this model. We're actually seeing there's a residual standard error of about $2,000. So our average predicted value is plus or minus $2,000. And there's an R-squared value of about 0.74 you can't see on the screen that's a little bit lower down. The mosaic package really does facilitate students querying models. It really takes on this modeling approach that Danny Kaplan has so ably kind of demonstrated. The MakeFun is not something to kind of be thinking about humor, but it allows us to turn a linear model object, in this case mod, into a function that we can query. Again, this looks very similar to how students have looked at functions in terms of their TI calculators in high school. When we say evaluate car fun for 2016 for a 1,000-mile car from Tampa, it says that predicted value for the model would be $22,875. I can then do things like, what's the impact, what's the difference kind of 1,001 versus 1,000 miles? And in 2016, that's saying that's about 24 cents. And I think I can just kind of scroll this down a little bit, and you can see that in 2012, that ends up being about 4 cents. So just querying this model allows us to kind of look at the same thing to kind of verify the calculations we saw from the previous slide. And there's a graphical way of exploring this as well. If we think about this relationship that, even it's not linear, I agree with someone who commented on my tweet when I sent these slides out. But the slope is dramatically steeper in 2016. That first year effect is pretty dramatic. After that, there is this relationship, but it tends to be attenuated. So lots of ways to take this, some of which I've done, some of which are kind of left as exercise for the webinar viewer. I often have students interpret and make sense of this model as an exam question. It's got enough moving parts with it. There's a lot of different ways of kind of thinking and having people kind of take those regression coefficients and just work with them to some extent. Looking at the residual diagnostics here is always interesting. Like if we go back to this this thing, what's with these two? Turns out they were both in one group, and I suspect there was data error involved in them, but they jump out in terms of any kind of residual diagnostics as being kind of miscoded values. We could explore other forms of relationships, some kind of nonlinear relationship between mileage and price, looking for outliers. And I haven't done anything about accounting for different car models. Partly this is a challenge that there's some sparsity in that and very inconsistent coding of how that's done, and also how people put their cars up on Cars.com. But that may be another level, because obviously there's lots of differences between the whole range of multiple Priuses. And finally, it might make sense to kind of think about following this up by automating the data scraping process, which is certainly a lot less tedious, but I think the students have a much greater appreciation for it, as opposed to just running a function that suddenly a data set pops out. We talked a little bit earlier about the Gaze College report. I think that this activity is really helpful in giving students experience with multivariable thinking in a context and a data set that I think is real to them, that has a context and a purpose. I think by having them work in teams of two, it really fosters an active learning as they start to think and debug and address how they're going to be moving forward to really focus on answering this question and to really use modern technology to allow them to explore concepts and analyze data. So just in closing, I think it's really important that students see multivariate examples early and often. I worry that statistics is often just, oh, that's what you do if you have small n and you just need to do a two-sample t-test. And I think statistics is far broader. It really is, to me, the discipline that lets students extract meaning from data. It's also important that we have students use real tools. And that I think was another message from the revised Gaze College report. These tools have gotten so much better, so much cheaper, that it really is possible for them to do a lot of things without having the kind of difficulty that was true even 5 years ago. So I certainly start them off with tame data. I don't want them in the first couple of weeks of the course to really have any bumps as they start to get up to speed. There's enough challenges in terms of understanding statistical concepts, but to kind of have them have some experience with less tame data like this by ingesting their own really does get them to start to think about data quality in different ways. Clearly, this would motivate automated data scraping procedures, as I mentioned before, but I think more importantly, it helps them to practice composing and answering questions with data. So that's what I've prepared. As I said, the GitHub repo listed below has all the materials that I provided, including the templates for the students, example of what some of those look like when the students have prepared them, and also the collated data in these slides. I'd be happy if there are any questions to answer them by email, or if there are any now, and turn things back over to Lee.
Okay, so if you do have a question, you can go ahead and type it in the window, and to kind of give everybody a minute to do that if they do have a question. I had a couple, actually. So what's the audience for this course? Who is this? Intro Stats?
Yeah, so this is our Intro Stats course. We have two flavors of Intro Stats. One is intended for students who've had some background in calculus at some point in their lives. It turns out that's more important to us than whether they actually have taken college-level calculus or the AP exam. And we're teaching about 80% of our Intro Stats sections for that kind of just, it's just a little bit more like an honors version. We call it Stat 135. It's an introduction to statistics with modeling. We also have a course that's more of a course for students without any calculus background, more of a general education course. And I've done this activity in both of them. It takes a little bit more time in that other group, but at that point they've actually been using R and R Markdown for a couple of weeks. We've introduced using R Markdown from day one really in the course. And when I have a class, we're teaching in a computer classroom. When I have a class of 30, there are 15 groups that are happening at one time, and I'm generally able to kind of move around to help them debug this in real time. When there's been classes of 50 or 60, people who've done this activity have had to have some other undergraduate assistant or other people helping the students to debug the individual groups.
Okay. Robert Root asks if you have a later project where students learn to automate the scraping.
Someone noted that. That's no, but that would be great. My experience with, RVest and the like, there's a lot of resources now that are out there that that let you do that kind of thing. I've not yet done that. Ben Baumer and I have a data science, the modern data science with R book, which has some examples of doing that kind of work. Again, that's more intended, in my mind, to be a more sophomore level data science course that we have this course as a prerequisite for. Certainly, I think that would be not an unreasonable thing to do. To me, it's less critical to be doing, and quite frankly, I've not done it, but I think it would be a great thing to do, and I would if someone wants to do that, submit a pull request or send me an email, and I'll put it into the GitHub repo.
My other question was just real specific. The MakeFun, MakeFun code, is that part of Mosaic?
Yep.
Or
that
okay.
is part of Mosaic, and one of the challenges I think in R is that there are lots of things that, you know, it was designed by programmers for programmers, so there are certain things that are harder in there than they need to be. For example, generating predicted values from a model. It depends on how you want to do it. Some parts of it are simple. Sometimes you have to actually create a data frame. So to do something like this in base R is kind of it's overly complicated. I wouldn't want to necessarily bring that in. And so Danny and Randy have come up with this MakeFun. There's an equivalent called PlotFun that lets someone actually print and display models. And in fact, this plot is the output of something called plot model. And so plot model will take a multiple regression model and plot the predicted values for that model. And so there's a variety of things that have been really set up in Mosaic to kind of help facilitate that and to really let students, because I need to do this whenever I describe an interaction to a clinician, I need to generate a table of values to give them some sense, or a plot like this that says, you know, it depends what year you're in, what that slope looks like. And some people will get it with the graphical display. Some people need to do these kind of calculations. I'll have the students once calculate this value to kind of verify that it is indeed, you know, 24.25 cents. But later on, I want them to kind of not have to worry about the calculations once they understand where these values are coming from.
I'm so sorry, my phone just went off. There was one other question. Osley Mutlo, I'm sorry if I didn't pronounce your name right, wanted to know in what part of the course do you do inferential statistics? Is it before all this, or do you do that after?
So I do that after. So we've structured our course such that students are working through the material that many of them have seen before, descriptive statistics, you know, simple graphs. A lot of that is actually now part of the high school curriculum, and students have seen it in various ways and places. And we move pretty quickly into the bivariate comparisons, really thinking about correlation and regression. And then but again, purely descriptively. That's just really understanding these parameters and assuming that they're known and fixed. And then move directly into multiple regression, but again, purely descriptively. How do you make sense of relationships like this? This is probably the upper bound of the complexity that we have there, where we're not paying any attention whatsoever. Tell the students to ignore the standard errors, the p-statistic, and the p-value, but just to be interpreting these things. And later on, we'll get to the fact that there's error and uncertainty there. So that really is coming in the first, you know, three or 4 weeks of the semester, and then we move into this point where we build the kind of, you know, underpinnings, sampling distributions, a little bit of probability, and then move into inference, but move very quickly back into inference through regression, as opposed to what I described as the long march of all these different things that are going to be confounded, you know, unless we can figure out some other mechanism to address that confounding. And stratification, do things separately by year, or multiple regression is going to be the answer to that as we kind of come back to it. So we've definitely brought a lot more into that descriptive regression and really thought about descriptive multiple regression.
Okay. He also wanted to know, because you did mention Excel as one of the softwares that you use for part of this, if you had the Excel commands available.
There's no Excel commands available because Excel is being used for what Excel is good at, which is storing data. And so the Excel is only used in this case for generating the CSV file, which then gets saved and then uploaded into RStudio.
Okay.
So, you know, the challenge for me is, we can get into kind of various arguments. I've not seen good ways of doing multiple regression and displays like this in Excel. And I think that's a big challenge for people who are teaching you with Excel, because I think it's difficult to really be thinking about multivariate thinking in that regard. There are add-on packages and other things. For me as well, I'm concerned if there's too much of a gap between tools that people are teaching with and then tools that people are using for professional practice. It used to be those were completely different tools, and now there's a lot more overlap. And so again, that would be, so Excel is purely used as a way of creating that spreadsheet.
Okay. All right. Well, it looks like actually, he just had a follow-up. Oh, I understand for Excel commands, descriptive multiple regression. Okay, I think you actually answered that. But if you need to follow up, you can certainly email Nick. So I want to thank everyone for coming out to our activity webinar. Again, Nick just put the slide back up that has a couple of websites where you can get all of the different resources he mentioned, and certainly you can email him and with follow-up questions. I believe when you log out there is a quick little survey if you want to give some feedback on the webinar. That would be great. Otherwise, I hope you all have a lovely Thanksgiving, and again, thank you, Nick, for sharing this with us today.
Great. Thanks, Lee. Have a great Thanksgiving, everybody. Bye-bye.